Hey everybody, this is Mr. Munson. We're in Unit 2, Circles. And so this is Concept 7, which is writing equations of circles, and then looking at the picture of circles and writing equations coming from the coordinate plane. So since this is Unit 2 and it's Concept 7, we're in 2.7, Equations of Circles. Let's get started. Let's first of all look at SLM. Now, hopefully at this point of the game, you have an idea what it means when I say SLM in the text messages or whatever. But let's say you're just one of those students who hadn't grasped it yet. I need you to understand that the three letters SLM stands for something very important. That's your student learning map. What I want you to do right now is put me on pause, get your student learning map out, and go read Concept 7 in the I can statements. When you read through those I can statements, those are the things that you need to be able to do when you leave this video today. If you can't, then you need to ask further questions in class or go back and review this video. Let's continue. Okay, I want to talk to you about some review of previous owned material from previous classes. So you're not taking notes yet, you're just simply watching. If I was to give you this equation right here, or this line, I could ask you to write the equation for that because you've had Algebra 1. Now, it might have been a while, but what we find out is if I just quickly reviewed it, you'll remember some of this. What we find is that if we take and write the standard form for a straight line like this, y equals mx plus b, it's called the slope-intercept form. We can look at the graphic to the left, pull information from it, throw it into the standard equation or the slope-intercept form equation to the right, and we can actually end up with y equals some numbers and stuff, which represents this equation. Let me again continue to remind you. I just pick any point on the line, and I'm walking to another point on the line. There's other points I could have picked, but these two are actually, circles, and I just know that these are on them, and they're at corners of the squares and all that stuff. So I'm just going to walk from one to the other. I walk up 6, and I walk over 9. Now, that 9 is in the left direction, so it's actually a negative 9. The 6 was in a positive up direction, so that would have been a positive 6. Now, slope, which is what I'm working on here with these two numbers, is a rise over run kind of condition. So my rise is 6 and my run is negative 9. Now let's simplify that, and it ends up being negative 2/3. So that's equal to my slope, and I'll stick that into my equation up above. All right, let's do that. Now I need to figure out what my b is, and all I have to do to get my b is I simply go to where the line crosses the x-axis, and I get negative 1/2 if I ponder that right. So the equation I need is this. That equation represents the straight line. I simply took in the problem here, I took that plus and that minus and applied it and just made it into a subtraction. Okay, no big deal. So hopefully you've had that before. Looking at an equation in a graph, you were able to write an equation written in the y equals kind of form. That's a standard slope, that's a slope-intercept form. Now what we're going to do in this section is do it with circles. So I'm going to give you circles like this and ask you to write the equation of it. And standard equation form for a circle looks like this. Now I want you to just put me on a pause. I want you to think through. You're not writing any of this down, right? We haven't started taking notes yet. I want you to think through for a second. What does that look like to you? What does that remind you of? You got something squared plus something squared equals the radius squared. Put me on pause. Then get going in just a second. We'll start taking some notes. All right, so make sure you've done the summary from the previous section. If not, draw a line right in the summary from the previous unit, and then go ahead and write a line across it, question mark, the line down the side of the page. Don't forget to put your date in there. You should be able to find these notes very quickly if I ask you to find them, okay? All right, so we'll go ahead and start taking some notes here. We have the standard equation given here is x minus h squared plus y minus k squared equals r squared. Okay, so let's see how we apply this to a problem given to you as a graph. So looking at that problem there down at the bottom, we're going to need some information. We're going to need two pieces of information. We're going to need to know what the center is as a coordinate and the radius. In this case, My center is P, so I'll call it XP and YP. If it was K, I'd do XK and YK. It doesn't matter. I want to show you the relationship of things that you've already dealt with, okay? Here's the distance formula. Now, looking over to the left, I'm going to say P is some value, some number of X and some number of K. I can see by the graph it looks like it's over 2 down -1, okay? But just for the case of us just talking, I just want to pretend like I don't really know what the X and Y value is for the P. So I'm going to call it H and K. It just represents some unknown letters. So I'm going to say that H and K represent my X and Y and some distance from P to this other unknown out here, okay? Some X, some Y. So I could say X minus H, those would be the two X values, right? X minus H squared plus Y minus K squared, and that would give me the radius. Now, if that just confused you, I need you to put me on pause and think this through because I'm getting ready to go into the 5-foot section of the pool, maybe the 10-foot section for some, and I don't want you to get lost. So it might be just backing up and listen to me and what I'm using for letters and just seeing how they go together there. So what I want to do is I want to get rid of that square root bar, okay? To do so, I'm going to have to take the square and apply it to both sides. If I take the square of the square root, it disappears. We've done with that several times now. So I take it and I square both sides. When that happens, I end up with this. R squared equals x minus h. Remember that h represented the x coordinate of my center. And then plus y minus k squared. So if you look at this, this is the standard equation for a circle. It comes from the distance formula, which comes from the Pythagorean theorem. I got something squared plus something squared equals r or something else squared. In this case, it's r squared. So here's a problem. Write an equation for this circle. Okay? To do that equation, I'm going to need two things. I need to know what the radius is equal to, and I need to know what the point, and in this case I'll just call it P, what the midpoint or the center point is, the H and K. So I'm just going to simply look at the graph, get that information, and then I'll write the equation for it. To get the radius, I'm going to simply walk from the center out to the edge of the circle in any direction, north, east, west, or south. I'm going to fix the circle. I can see that it's not exactly where I want it. I'm going to fix it here real quick. You'll see what I do. Okay, so I just go to the center, and I'm going to count out in any direction. If I go this direction, I'm off the graph, and so I'm going to just go ahead and count to the north here, and I find that the radius is actually equal to 3. Now to find the P, I'm just going to look at the graph. Here's the origin. So it looks like the graph or the center is at 2, comma, -1. Now I'm ready to write my equation. So now I'm just going to fill in with the other information. The more you write it, the better you get at. Always write the same way. It kind of follows the Pythagorean theorem. Whoops, that should be an equal sign right there. So I take my center point, which I found earlier. I throw it in there. I'm going to change the r to the 3, which is r squared. And now I'm just going to kind of walk through this and clean it up a little. And there's my equation. Pretty easy stuff. It's just going to be a matter of you memorizing what the standard form of the circle is, what two pieces of information you need, and then writing the equation out. Okay? Let's have you do one. All right. It's time for you to try it. Put me on pause. Come back and check your work. If you did not do this, you should have written the original standard form for an equation of a circle first before you start doing anything, right? Two pieces of information I need is the radius and the center. So I'm looking at that information and I've got that. I take the H and the K and I plug it into standard form as well as the radius. And there you have it. If you're not sure what we did, then you should go back and review this section again because you're going to have to do a do-it problem on this. Okay? Now let's just take a quick second and look at something. Now if you take a look at the equation, you're also going to have to be given an equation like that and you're going to have to draw the picture to the left. So to do that, you're going to have to be able to decipher what's going on here. Notice that when it's a minus, there's a 1 there, and then there's a plus. And if you remember, our original center point was -2, comma 1. So you're going to have to, in your mind, understand that when it says like x plus 2, the center point's actually a negative number. When it says y minus 1, that the center y value is a positive number. And then when I give you this, you're going to have to realize the radius is not 16, but the square root of 16. So let's take a look at an example. Draw the circle that has the equation x minus 2 squared plus y and so on. Okay? So I need to figure out what's the radius and what's the center point. Okay? Now, once I get that, then I'll just plot that information and I'll have my circle. So it's all in the process, and especially with the radius. Okay, so we know that because r squared is what's sitting over there, we should write r squared equals 36. All right, sorry for the change over there. But I want to know what r is equal to. So to do this, I'm going to have to take the square root of both sides to find out what r is. Because when I take the square root of r squared, that's what gives me that r. Pause if you did not understand that and go back and listen to what I just talked about. Okay, make sure you take good notes on that. So r is the square root of 36, known as the number 6. Okay, so that's part of my answer there. That's going to help me draw this equation. Now, just remember what the standard form is. We already have the equation and everything. I'm not worried about the left or right-hand side of the square. I'm trying to find the center point. So when I take what I'm given, the x minus 2 and the y plus 3, I notice that this is the same as it's supposed to be. This is the one that changes. So when it changed, it means that there's a negative there. I like to just look at those numbers and see a -2 and a +3, even though it's addition and subtraction, and just say, you know what, my center point has to be opposite of that. So just pause for a second and soak that in and ask yourself, do you understand why it's 2 and -3 and how you're going to remember that? I just look at those numbers and say it has to be the opposite of that. So I'll go plot the center point first. If I did that right, it's over 2 down 3. My radius is 6, so I'm going to basically walk 6 units in the north, east, west, and south directions. Don't worry that you're off the graph, right? You can just kind of estimate it. And then I draw my circle the best I can. Okay. You get better at it if you do it. And now that's the equation drawn in graphic form on the x and y axis. All right, now it's time for you to do it on your own. Draw the circle that has the equation x plus 1 squared plus y minus 3 squared equals 9. Okay? Put me on pause, see what you can do. Now, I always like to draw or write out the standard equation for a circle so I can kind of analyze what's going on. It also helps me remember that the thing that's given here is r squared. To draw my circle, I need to know what the radius is. So that writing that form underneath it helps me remember I'm going to have to take the square root. Okay, so I noticed that the x minus h in this case, the minus is turned into a plus, and then the y minus k stayed the same. I just remember to take the opposite of what I say there. I say a +1 and a -3, so I'm going to take the opposites. Find the center. I love doing it. It's so easy, right? It's going to be the opposite of -1, so or +1, so it's going to be -1, comma 3. Okay, just opposites. All right, so now we have to do the radius. Now the radius that's given is 9, but it's the radius squared that equals 9. So I always write that down first. R squared equals 9 to help me remember that I have to take the square root of both sides to get it to be r. Okay? Once I take the square root of r squared, I get r equals 3. So the radius is 3. Now it's time to graph. And there you have it. Okay? Well, here's the word summary that tells you we're done. And so make sure you just take a few moments, go back and write a good summary. This is for the stellar student. This is for the student who wants better than 75 or better. The below average student is writing stupid stuff and things like that. You want to be better than that. You deserve to be better than that. And so you just take the few moments and be successful. Write your summary to the best of your ability. Just look back at your notes and see what kind of things we did. And then let's go to our try it or do it problems. It's just two problems. One, write the equation. And then two, draw the circle. Okay? Have fun. I can't wait to see that as an excellent return do it problems. Don't forget to put your name date over at the left hand side. Put the title at the top at 2.7 equations of circles. You're awesome. Let's go on.